Go on.
Hello, hello, hello.
Hello. Welcome to Science Scribbler Q&A and Classify. It is July.
It is.
And we're coming to you from the UK heatwave. Woo!
Woo.
Yeah. My name's Trisha.
Yeah, there we go. My name's Michelle.
And today we've picked a project. I'm quite tired, so we've picked a project that is maybe like slightly less reading, slightly more colours to classify on today.
Yeah.
And it is called Spiral Graph Cluster Buster.
Yeah.
So let's find it. There you go.
Okay.
Okay.
I like the neon, first of all.
Yeah,
That's
very
lovely.
colourful
Takes
swirls.
me back to the 80s.
Sure.
Are you old enough? No, you're not
No.
old enough for that. Okay,
Yeah.
so we are doing astronomy, it looks like.
Yep.
Yeah?
Yep.
Help us determine if the tracings of galaxy spiral arms are clustered correctly. Okay.
Yep. So this is the second part of a project, or the second project from the same, I guess, research question. Spiral Graph was the original project.
Yeah.
And that's where all the tracings come from of these spiral arms of galaxies. And we are now proofreading the outputs of an algorithm that has tried to cluster them together.
Okay.
Yeah.
That sounds good. So it looks like there's only one workflow, so let's get started.
Yeah. And it's also a yes/no question.
Ooh.
I found, yeah.
Okay. Let's go through the tutorial. So previous project, Spiral Graph, people were asked to trace the spiral arms, and they've got a video of that process where someone is laying down a spiral. Good. And that produced these types of images. There's usually some agreement among tracings as to where each of the arms is. That's nice. And then they've got an algorithm that attempts to group similar tracings together into the individual arms while ignoring obvious outliers.
Yeah, so some of the lines appear like they stay grey because they've been classified as outliers in the colorings.
Cool. This is important because they say our goal is to measure the degree of winding for each individual arm in a galaxy. So I assume that if they took each of the individual like magenta tracings, that they would get different degrees of winding from each of them. And so they need consensus in order to do that. So, okay. So we need to tell us if the colored clustering performed by our algorithm actually represents the distinct galaxy arms that you can see in the gray tracing image, comparing the colored clustered image with the gray tracing image. Here it's overlaid, so you can barely see the gray other than where there's outliers. Okay.
Yep.
So yes, it is successful in this case. Okay, so let's go back up.
Yeah,
yes.
quite happy with that.
Fine.
Yeah.
Okay, and then, oh, it's quite small. They should really zoom that in a bit. But in this case, the gray tracing image shows a galaxy with 3 arms. Unfortunately, our clustering algorithm has grouped 2 of these arms together into a single magenta cluster. When there's a clear gap between spiral arms, even if they appear to merge or split, they should be indicated as distinct structures. Okay, so they're essentially saying that these 2 things here are distinct structures.
Yeah.
Okay.
I think we've got a good example of that behind us, actually, in the one we're going to look at first.
Oh, yeah.
Can you see that there's like the 2 blue lines?
Oh, yeah, these 2 here. Yeah, okay, fine. So then it says say no in the task. Note the number of clusters our algorithm found in the image can be viewed by clicking the subject info link on the bottom left side of the viewer. Okay. Interesting note, but all right. So then tools along the bottom and right side of the viewer allow you to control and customize your view of the data. So it looks like you can go from like a stacked image to 2 images side by side, which is nice. And then you can toggle pause play, bottom left button, speed.
Yep.
And you can manually click through. Thank you. Okay. And then we got a light and dark mode as well. Okay. Did I skip something?
No, I don't think so. I think it really is. It really is that simple.
Yeah, and then there's a talk thing.
Yeah.
If you need it. So okay, let's get started. Okay, so default it shows the 3 images left to right, which I think is nice.
Yes.
Yeah.
Yeah, and it's not, I don't think it's fully clear that the first one is a composite of the other two.
Yeah, agreed. So
But
I was just going to say that
yeah,
this is both of the images, and then these are the two individual images.
yeah,
Yeah. Okay, cool. And I think we both agree that
yeah,
those should be two separate things. I find it really interesting that they're not showing us the raw data,
yeah,
the underlying data. They're just showing us the tracing.
yeah. But I
Yeah.
think like some of these spiral arms can be so diffuse and like low intensity that
Yeah.
it's quite difficult to work out where the middle line is.
Yeah, and I think they probably also they don't want to relitigate the
Yeah.
tracing step. They've done that. They have a lot of data on that.
Yeah, we don't get to decide if the tracing is bad or not.
Yeah. They're more interested in knowing if the algorithm has correctly separated. So we're going to say no. And then done. Okay.
This is an interesting one where I think maybe there could be a third arm that's been missed by the clustering.
You
but
think
just
this?
a really short, small one. Yeah.
Yeah, so like here or something,
Yeah.
and then it's got like a diffuse tail that joins in with that, maybe.
Yeah.
Interesting. Let's have a look at the field guide because I feel like it'll show more examples. Let's look at examples of unsuccessful. Arms not clustered at all, so we've just got
A missing arm.
one.
Yeah.
Yeah, missing arm. Set of tracings at 5 o'clock is not clustered into an arm. Oh, yeah, so it's just kind of missing that arm there.
Yeah.
Yeah. The arm at 12 o'clock is missing in this unsuccessful clustering attempt. So.
Yeah, there's like a small one
This one?
there. Yeah.
Yeah. Yeah, and it's just kind of been joined in with that somewhat. Okay. Sometimes the clustering is unsuccessful because the traced arms bifurcate or split into two branches. Okay. Did it tell us? In the example, the magenta arm bifurcates on the right side of the galaxy and fails to be clustered as a separate arm. Successfully clusters the blue bifurcation.
Yeah.
I like how they say surprisingly.
I guess because within one image you wouldn't expect to have
that one worked, but it's missing these things here.
Yeah.
Yeah. Okay. I don't like that they're using like quite technical language here, like bifurcation and things like that. Like that, I think that's not a common word.
Yeah, I'm only like assuming what it is based on the context of
the
what
image.
We're reading. Yeah, exactly.
Yeah, exactly. Yeah, separate arms in the same cluster. There are times when our algorithm is not able to distinguish individual arms and incorrectly clusters them together. The single yellow arm cluster should have been split into two separate. So it just had all of them into one. Okay, fine.
It did its best.
Yeah. You know? Make up the magenta cluster are initially bifurcated at small radii and then combine into a single arm at larger radii. Ooh, okay.
I think that's quite a hard thing to get an algorithm to do. Like, what would be the definition of success here? If the arms merge together again, do you want the whole arm, like the whole tracing, to be split into two at the beginning and the end, and then the middle you see the clear distinction?
Yeah.
Yeah.
And this is where it might be helpful to have, like, instead of just showing this example and having like text to describe, having like an expert's tracing laid on top of it would be helpful to tell us like what is expected maybe or what isn't. But again, that might have been something that was done
for the previous project. Yeah.
But it's still helpful here for us to just like see where it's wrong even.
Yeah.
Two traced arms incorrectly clustered together as a single magenta arm. Yeah, so like a bifurcation. So like I am leaning a bit more towards like this being a thing.
And it's been missed.
Yeah.
Even if it's the blue one splitting into two.
Yeah.
Like
yeah,
that one
see like
there.
this one here, right? Because it two different arms perhaps. I think you could make an argument for like a second arm here.
Yeah.
Not necessarily going all the way around and all of this stuff, but like I think there's enough tracings through there that it's probably real.
Yeah.
So, okay, cool. Arms clustered too much.
Overfitting.
Yeah. So I guess that should be 1 and it instead went for 2.
Yeah.
Yeah, exactly. Yeah. A lot of noise in the tracings. Successfully ignores these outliers. Still encounter a case of overclustering. Blue and magenta clusters are part of the same arm and should not be separate clusters.
This is a good example of, yeah, where people have,
There's X's and
yeah,
there's just circles all off to the side and things. Yeah.
yeah. Reminds me of the one etch a cell example of,
Yeah.
of like being able to clean out outliers like that.
Yes,
Yeah.
yeah, exactly. Where they just wrote something like, I don't like this or something. An extreme case of outlier data successfully rejects. Blue and magenta clusters appear to be part of the same arm and should not be separated into two. Okay.
Yeah.
Yeah. Which is probably just confused because of all of that extra. Okay, so we agreed on no, it's not good.
Yeah.
Yeah, done. All right, what do we got here? We got blue, we got red, and we got a green. So I think the question is, do we think red and green are two separate things?
I think if I look at it, if I look at just the white example,
Yeah, on the right.
it looks like there are just two arms. But what's happened is some of those have been detected as outliers, which has led to the distinction between the red and the green.
Yeah, exactly.
And I'm not sure whether it should be like that.
No, I don't think so. I think this is wrong because that's just one. That's just one diffuse arm would be my suggestion.
Yeah.
So say no. We've gotten so many that are wrong.
Yeah.
We haven't gotten any that are right yet. Oh,
wow. And sometimes it gets a bit complicated.
Oh, you don't say. Timing.
Yeah.
Okay.
But it's so colourful, so it's quite nice, really, isn't it?
Yeah. Okay, so we've got like one strong one here, which maybe has a tail over there, but it's been clustered into one thing. Yeah?
Yeah.
And then it's showing orange being this thing off to this end.
Yeah.
And then we've got like a purple that's coming out down here and a blue in the same space.
Yeah.
And then a green that's coming all the way over here.
Is there like a cyan as well, or is that overlaying? Because sometimes the colours can look overlaid. Oh, we can look at the number, can't we?
We can look at the number. Number of clustered arms, 5. Okay. So red, orange, blue, purple, green.
So the cyan
I think
is just
the
blue
overlap. It's just the overlap of the blue and the green.
Okay.
Yeah.
Interesting.
Yeah.
So I feel like the answer is no, just because it's taking us so long to work out whether it's right or not.
Yeah, I think it's no because of this purple-blue situation. I don't think those are two separate arms. I think that that's like the green. Yeah, and then the blue and the purple or something. So like the blue should be part of either purple or green.
Yeah.
Yeah. And then I also think that there might be like something going on here that's missed.
Yeah, because there's a couple that have been classified as outliers.
Exactly.
There. Yeah.
So I say no.
That's a no.
That's
from me.
No, yeah, obviously. I'm really surprised that they aren't asking us to classify the no's.
Oh, as why it's a no.
Why it's a no.
Yeah.
Yeah, because that must be useful information for them.
Yeah.
Because just no is like.
Yeah.
I mean, or maybe they.
So I looked at that. I've been looking at some of their presentations that they've given to conferences, and it's my understanding that part of what we're doing in proofreading is training the hyperparameters.
Okay.
For the clustering algorithm. So it's possible that there might be that twice or 3 times in the data set, but with different parameters.
Okay.
I don't know whether that's the case or not, but if they've done that, then it's more kind of working out what the optimal,
parameters are,
exactly,
rather than like the actual
exactly why it's failed
outcomes. Yeah. Okay. Yeah, interesting approach if that's the case. Because I would have thought that if you're trying to retrain, or even in that case where you're trying to work out hyperparameters, you may want to know why it's failed,
which mode of failure is
causing like an increase in this type of, like which hyperparameters is causing an increase in this mode of failure or something like that. But
equally it's one question, which means it can be done on the app.
Yes, that's true. So, there's always that downside of like making it more complex and therefore missing out on the app. The other thing that I was thinking is maybe they've specifically chosen, like maybe they have an algorithm that clusters and then they have an algorithm that detects errors.
Yeah, and they've chosen
automated proof,
the bad ones.
And they've because all of these are bad, right? And they've specifically chosen the bad population for review. But maybe because they've got some sort of indication that it's bad, they already know why it's bad.
Right, yeah.
So they don't need the human to do that part. Maybe. That's a guess. Total guess.
Yeah.
Yeah. But anyway, no.
I wonder whether they have the data also from the original tracings in the original project. If they asked people to trace them, and then also they know how many tracings on average are put, like how many lines did people put down, and that might be the expected number of clusters to find.
Yeah.
Yeah.
Mm.
I think that's right. Well,
yeah, I think the only
yeah.
question is up here because the two that are kind of up there are outliers.
Yeah.
But I think with just one or two or three there, it's not enough for me to think it's real.
Yeah, I'm feeling generous.
Yeah. Our first yes.
Is it really?
It is.
I think I've given some yeses when I was trying it earlier.
Okay, cool. My first
yes. I always get the benefit of having looked at it already.
Yes, yeah, exactly. Yeah. Okay, we've got a yellow coming out here and joining up with that green. We've got a green coming around. Then we've got a blue that seems to be both here and here. And then we've got a red, maybe a pink. Let's see how many. 6. Okay.
I actually, in that subject info, there might be a link to the galaxy because it's the legacy survey image. Yeah. Well,
we're just gonna click on it.
No, we don't have to. We can find them later. But I think that what happens is you link to the actual survey data.
Okay.
Yeah.
Oh yeah.
So
we could look at it if we wanted.
Whether or not the annotations are bad.
Yeah. But it's hard because there's not overlaid or anything, so it's just the raw data.
Don't want to just like switch between tabs really quickly. Yeah.
Let's not make everyone turn off.
Yeah.
Yeah, but okay. So 6 is what we're aiming for here. So yellow, and then green, and then blue, and then there must be a pink here.
Yeah.
And a red, and that's still only 5. So I'm not even seeing a distinct 6th color here.
Unless it's an orange, or is there a dark purple in there if we zoom into the central one?
Oh, it's a bit annoying that they don't zoom all of them at the same time. Yeah, there's a purple here that overlaps with the red.
And if you go to like the right hand side of the image in there, is there any purple?
No, just blue overlapping with the red. There's an orange though, look at that.
Yeah.
Yeah. Okay. So I think it's wrong.
I can't tell you exactly why it's wrong.
Yeah.
But it feels like it's probably
wrong.
Yeah.
Yeah. Well, they don't have a home button so that I can just click that. Reset. Yeah. There we go. That's it. Yeah, definitely wrong, but like the Y, definitely that is wrong. And then I think this yellow probably is made up too. I don't know. It's a bit hard.
I wonder if the yellow should actually be the pink, because there does seem to be that loop that goes in, but which yellow is part of, but it's also the pinky color.
Yeah, I mean, I think there's something here, so like 1, and then there seems to be something that goes off here 2, and 3, and like 4. I don't know. Let's go look at the real data. Now that we can.
Yeah.
Yeah. It's opposite. It's rotated.
Oh, yeah.
Yeah, but so 1 with like a tail that way and maybe a tail that way. I don't know.
So they do that? 2 there. Yeah, because they can 2. Split.
And then 3 going all the way around to here.
And then I would say
and then maybe the 4th one here.
Yeah.
Yeah, but 4 only, not 6.
The one that goes straight up to kind of the clumps at the top, I don't think.
You mean these
yeah, because it could kind of split off there, but I don't know.
That's a bit amorphous for me. I don't think that that's part of it. But no expert.
Yep.
Okay, and the downside of this now is that my zoom bit is on top of where I need to click to close. And like get back to so we're not gonna close that. We're just gonna remember that it exists. Answer is no. Okay.
Now this one might actually only have 2 with the white overlay.
Yeah, so let's check. They really should just print it. Like there's no reason they couldn't like print it in the corner of the image or something like that, because they're already having to like separate these images out and do a bunch of stuff to get them to like come together.
Yeah.
And it's useful information, so they might as well. 2. So the question for us is there 2? And I think there's 3.
Yeah.
Yeah.
And there are 2 that have both been classified as red, maybe?
Yeah, well, so this one here has been classified as blue, And then some of the blue also comes
Yeah.
down to this one. So this one is misclassified as a single blue object when it should be a third object.
Yeah.
And then the red, I think, is generally fine, although does continue here when it probably shouldn't. So we'll say nope. Oh, okay. So I think there's 2 here that it's
So
missing.
I think it's still no, isn't it? Because it hasn't been split.
1, 2, and then that one is fine, and then that one is fine. So no. Everything's a no. Maybe I'm just the lucky charm. Is it a good thing that it's no or a bad thing? It's hard to know.
Is it? Yeah, I don't know. It's exciting to get both.
It would be nice.
Yeah.
Yeah, it makes you feel more useful rather than it just always being the same answer. But anyway.
This one looks the raw annotations look quite messy.
Yeah.
So I wonder if some of them are just not very good, because there's kind of these like circles that have been drawn right in the center.
Yeah, 1 or 2 there. But I think it's done a good job with it.
Yeah, with getting rid of the noise, definitely.
So this blue one looks correct. This orange one looks good. And then the purple one, I think, is fine.
Yeah.
And then you've got a red one that kind of comes in here. And it does a decent job of picking up the green one there, too.
Yeah.
So I think it's right.
There we go.
My second.
Yeah. 2 out of who knows how many.
This is a no.
That's a no.
Easy no.
Only
easy no.
I would say no because it's just not correctly picked up the whole spiral.
Tail of that. Yeah.
They are clustered correctly, but all of the tracings are not in the right clusters. There are just the right number of clusters.
Interesting, because it's like right on the edge. So some of them are just artificial because it's on the edge. So their box size wasn't big enough.
Yeah.
Excuse me. Okay.
I wonder if it's had trouble with that, because there do seem to be. There's like a blue and a red both dealing with that top section there.
Yeah, and like very few of them have been left. So the algorithm must not expect really sharp lines like that, which would make sense because everything generally is rounded. But it can't be rounded if you can't be in the image. So, but okay, so we've got a green one that does this. We've got a red one that does this.
I want to say no, but I don't know why.
And then we've got a blue one that does the same as the red one, which is wrong, I think, because it doesn't really split anywhere. And then we've got this split for the yellow. And we've got something down here that's missed. We've got an orange that comes here. And then we've got a purple that starts from here and goes down. So yeah, definitely a no.
Yeah.
Ooh. I think there's 1 and then 2 would be my read of that.
Like a messy 2.
Yeah, so a messy 2 rather than just a single one. Nope.
Sorry. I wonder, that feels like one I've seen before, you know?
Ooh, okay.
It feels similar enough to maybe the one we had at the beginning or one in the examples.
Let's go to the about and just have a little look.
Yeah.
At like what they're doing. Okay. Yeah, your classifications will be used to train an AI that we are developing. AI will select the appropriate parameters for cluster tracings into individual arms, and your contributions will make our AI more effective.
Yeah, so maybe rather than trying to do kind of global hyperparameter optimization, they're trying to get like the decision of which hyperparameters to use on a per galaxy basis to be like intelligent but automated.
Well, because to do the hyperparameter tuning, you have to have what computer scientists call ground truth, but is not in this case ground truth. And so this is them bypassing the need, I think, for ground truth or expert annotation. Okay.
Yeah, this is why it's important, which I admittedly glossed over because I was trying to find their actual algorithm.
Okay, so not always symmetric, and their individual arms may differ. Some are longer, some are bifurcated, some have a different pitch angle, a measure of how tightly wrapped a spiral arm is. Okay, true, fine. Pitch angle measurement software assumes the input image is perfectly symmetric. This means that if a full image of a spiral galaxy is put into the software, it assumes the arms are logarithmic spirals of equal length and pitch angle, with each arm's starting position evenly spaced around the galaxy. Measuring the pitch angle of each arm individually rather than altogether lets us bypass this assumption of symmetry.
Yep. Which matters, I believe.
But so they haven't explained why it's important.
I think in the FAQ you might get a bit more information.
Okay.
I think also, it helps you assess something. Yeah.
Okay. Also, they also just say like I know I just said also like 10 times. They are just saying their software can't handle it because it's not symmetric. But that doesn't explain why the software can't handle it, and this is the better option than software development.
Because their software is just a 2D fast Fourier transform.
Okay, which therefore relies on symmetry.
Yeah. But there are a lot of the now you're exposing that I've deep dived and read some of their paper paper.
So they do have a whole separate section called the impact.
Yeah, go on.
Which was not up above where it said why it's important. So let's read this before you go into other sources. Okay, help us choose right settings. Properly tuned clustering algorithm will let us group the tracings into separate arms more accurately. To measure the pitch angle of each one, we hypothesize that this will help us more accurately determine the overall pitch angle of non-symmetric galaxies. Okay, again, haven't told us why we care. Pitch angle of spiral arms relates to other parameters, more difficult and time-consuming to measure. Mass of the black hole found in the nucleus, bulge, stellar mass, galaxy total stellar mass, maximum rotational velocity, and dark matter content of the galaxy.
Yeah, important things.
But why?
Why are those things important?
Yeah, all they've said is it's a proxy measure for all of these other things, but they still haven't told us why those other things are useful or interesting to know, other than it allows them to identify interesting galaxies so that they can look at them more closely.
Yeah.
Like, yeah. Let's read the example. Hold on.
Maybe the next sentence is going to tell you everything you've ever wanted.
Maybe. Rare black holes in the centers of large galaxies. Masses that range from hundreds to hundreds of thousands of times the mass of our sun. Intermediate black holes.
So I think they're looking for small black holes, basically, to understand how they develop. So like young ones.
Yeah. Okay. I guess.
Yeah.
Like it's always like a question when you work in science, right? In science communication, especially, as you're aware, right? Like how far do you need to go in order to demonstrate impact, right? Or like to make it so that the man on the street or woman on the street or child on the street cares.
Yeah.
Is usually like the kind of uncouth way of saying that, right?
Yeah.
And like I want to look at black holes. Like that sounds cool, sure, but like the why is still a big question.
Yeah. But I think that we're like, as scientists, we're trained to like talk almost chronologically.
Yeah.
But like when you do science communication, I've always been told the most important message you want to give needs to be the top.
Yeah.
Like the catch line or like the first paragraph only.
Agreed.
And that's where you hook the reader.
And I just want to point out that we're literally at the very bottom of their about page on research, and there's finally like an example or like a couple sentences that describe why we want to do this in a way that like makes it somewhat real.
Yeah.
So like no hate or anything obviously, but like it's just very hidden maybe.
Yeah.
So anyway.
So the paper.
Yeah, sure.
Yeah, it was comparing different like different ways of modeling these spiral arms, but I think almost all of them are symmetrical, right? Yeah. So all of the mathematical models are symmetrical.
Mm-hmm.
I don't know how dealing with asymmetry like this, it seems like they then might aggregate it into a single like value of pitch for the galaxy anyway, which I don't really know how that works.
Yeah.
So like I don't know how you can, whether the like the measure of asymmetry is important in inferring something else or not. But yeah, they've done some stuff where they're comparing kind of their traditional method that's symmetrical with other methods out there, and yeah, whether asymmetry is important.
Okay.
And I think there is a paper already which has some of the citizen science contributions out there.
Yeah.
Yeah.
Cool. Yeah, no, that's good.
Yeah.
That's really good. All right, shall we do
Let's
5
find
more?
the next yes.
I just had 2 yeses in a row.
What are we doing? Like 5 or a yes, or like 10 or a yes?
Let's do 10 or
10 or a yes. Okay.
10 or a yes. Although this might be a yes, we'll see. So that's the red, that's the purple, that's our blue, and our green.
Yeah. If I was picky, I'm not sure the purple extends the whole way that it should.
Yeah.
But
they don't really talk about that.
Yeah, I think that's maybe something I noticed that it's unclear whether if it's correctly clustered them, but it's not gathered all the lines you would expect to be in there, is that good enough or not, right?
It's not really asking us to look at the outliers and say, are these outliers really outliers?
Yeah.
Yeah. But maybe let's say no anyway, because it's questionable.
Wow.
Ooh, okay, there's a lot of outliers in here.
I think that it's missed one. I think the blue one might split and then merge again based on some of the tracings.
These? Yeah, that and that. Yeah, I also think like this is part of the red one here.
Yeah.
Or possibly the green one, and the blue starts up here. So they've got a couple things wrong. 2. Oh, definitely missing whatever this is.
Yeah.
3.
I think that could be a yes.
I think you're right, other than this bit of red down here.
Yeah. But I think if each line is an individual volunteer, then you might expect someone to merge 2 together like that because it's probably more diffuse there, right?
I guess we're ending.
Yeah. We came to the end. Wow.
Thanks for coming with us on this journey. I had some fun. I don't normally do astronomy-based ones.
Right, yeah. We haven't done that many. Yeah.
So that's fun.
Yeah, it is fun, and there's a lot of them out there. Yeah.
Cool. Well, let us know if there is a project that you'd like us to try during our next stream. And we will see you next time.
Yep. Have a good heat wave if you're in the UK. Bye.
Bye.